Hello, welcome to Prep Station 224. I'm here to take you on chemistry and also answer some questions very easily in your JAM examination. So I want to take you on 5 major topics on chemistry that JAM always pick their question from. The first topic is electrolysis. On this topic, we look at the definition of terms, then also look at factors affecting the discharge of ions, then examples of electrolysis. We now look at the Faraday's laws and the calculations. Then later we look at some past questions related to electrolysis. Okay, so what is electrolysis? It is a chemical decomposition of a substance in its molten state when electric current is passed through it. That means that there must be a breakdown of compound, but this compound must always be in a solution form or in a molten state. Then there are some few terms that are relating to electrolysis. In which I'm going to be so brief on it. The first one is electrolyte. Electrolyte is a substance that contains mobile ions, okay, and undergoes decomposition when electric currents pass through it. Then we also have what we call the non-electrolyte, which is the opposite of electrolyte. Now, if electrolytes are molten ions, okay, compound that decompose when electric current passes through it, then what do you think should be non-electrolyte? This is the opposite. Now, this compound does not do what? Conduct electric currents. They are otherwise known as non-conductors of what? Of electricity. All right, electrodes. Electrodes are, this can be in ions, can be in rods or plates that do what? That allows what? Electrons, okay, to enter into what? The electrolyte. Otherwise, we can also call them what? Conductors of heat and what? And electricity. Now, electrodes are being divided into two. We have what we call the anode and also what? The cathode. Now, what is the anode? Anode is a positive electrode which allow electrons, okay, to leave the electrolyte or allow what? Current to enter into the electrolyte. Now, the work of anode is of two types. One, it allows electrons to do what? To leave. In other way around, it allows what? Current to enter into what? The electrolytic cell. Whereas the cathode does the opposite work. The cathode is a negative charge electrode, okay, which allows electrons to enter the electrolyte, but allow current to do what? To leave the electrolyte. We also have what we call electrolytic cell. Now, this is a device in which electric energy is converted to chemical energy. It's made up of two electrodes, okay, with a cell, cathode, anode, and electrolyte, in which electrons are being split and discharged appropriately. Now, in this kind of setup, all the negative ions will be attracted to what? To the positive electrode, whereas all the positive ions will do what? Will be attracted to what? To the negative what? Electrode, by electric currents do what? Passing through what? The electrolyte. At the end of this, chemical energy or what is converted to what? To electrical energy. Now let's look at another setup which is called electrochemical what? Cell. Now this is the reverse of what? Of electrolytic. This cell converts chemical energy to what? To electric energy. Now in these cells we have two setup, okay, with a salt bridge. As you can see in the diagram, this salt bridge now do what? Maintain electrical neutrality between what? The two apartments in this what? Cell. I will not go too far on this because JAM do not really pick much question on this aspect. So but know that the electrochemical cell is a device that convert chemical energy into what? Electrical energy. Now, what are the factors that affect the discharge of ions during electrolysis? The first factor is the position of ions in the electrochemical series. Now, this particular factor has to do with what? The reactivity of what? Of the ions. How positive or how negative what the ions are. Now, the ions that are more electropositive will not be discharged during the electrolysis. But those ones that are lower down what? The group. For example, look at this this setup. Now, we have cations and what? And anions. Anions were attracted to what? To the anode, which is a positive what? Electrode. Whereas the cations will now do what? Move to the cathode. Now, the electrons that are below, for example, silver, copper, hydrogen are below what? below in the table. Now, in electrolytic cell, in which you have calcium, for example, magnesium, for example, and silver, for example, it is silver that will deposit, okay, in the electrolyte rather than what the either calcium, sodium, or magnesium, because these compounds are more electropositive than the one below the group. Likewise, the ionic cell, we have the OH minus as a lower ion here. Moving up, you have the SO4 2 minus. Now, if these two ions are present in a electrolytic cell, it is the one that is lower, okay, that will be discharged at the end of the process. Now, the next factor is concentration of the ion. Now, this one works when the two ions are close by. For example, I will take you back to the cell, to the electrolytic cell or reactivity series. Let me use the anion for example. If you have electrolytic cell that contains bromine ion, chloride ion, or iodine ion, now these ions are close by. So we're not going to judge the discharge based on the position because the ions are close. Rather, because they are close by, all of them have the tendency to be discharged. But the actual one that will discharge is is the one that have more concentration, which is your chloride ion. So chloride ion will discharge because of it has a higher concentration than iodine, hydroxyl ion, or bromine ion. Then the last factor is the nature of electrode. Now this one depends on the reactivity of the ions and the electrode. Sometimes the electrode can react with ions and form amalgam. Okay, so but the major two factors that involved here are the first two, which is the position of ions and the concentration of ions in the solution. Now let's look at some examples of electrolysis. First of all, electrolysis of dilute H2SO4. Now, in this electrolysis of H2SO4, you're having 3 ions. Now, the first ion we'll have there will be H+, because water will be used to dissolve the H2SO4. So H+ will be gotten from where? From water and also from H2SO4. Then when you now decompose the H2SO4, you're going to have OH from the O for water and also have SO4 2 minus from the H2SO4. So all these ions cannot be discharged at the same time. Because here we have 3 ions, so it is only those that are positive, okay, that will move to the negative electrode, which is the cathode. Whereas the ones that are positive will now move to the negative electrode, which is the anode. At the course of this video, I did not go very deep on it. So visit your textbook and more research to check what happens at the cathode, at the anode, and their overall reaction. But here I will just give you a brief summary of it. Now at the cathode, H+ will be discharged, okay, and do what? And takes up an electron. Don't forget that reduction takes place at the cathode, while oxidation takes place at the anode. So H+ will do will be discharged, okay, and takes up electron and become a neutral atom with a chargeless neutral atom. Now this H is not balanced on its own. Okay, it must recombine by itself and give us an hydrogen atom. So in that reaction, you're going to have H+ plus E- equals to H2, okay, in the cathodic equation. Then what happens at the anode? At the anode, you're going to have 2 ions, which are the OH ion and also the SO4 2 minus ion. In this case, you now go back to the factors that affect the discharge of ion. Now, because the OH is far below SO4 2 minus, according to the diagram you just see here. Now, it is the OH that will discharge, okay, not SO4 2 minus, because of what? Because of its position in the series. Now, when this is done, the OH will now do what? Will now lose the electron, become OH on its own, which now later recombines to give us water and O. Then O will now recombine to give us oxygen. So here at the anode, it is oxygen gas that is produced, while at the cathode, it is hydrogen gas that is produced. Please consult your textbooks, okay, and see the reaction that takes place. Now let's move to the next thing, which is the laws of electrolysis. Now, the first law here is called Faraday's first law of electrolysis, and this law states that the mass of an element deposited during electrolysis is directly proportional to the quantity of electricity passed. If you look at it in the way of mathematical expression, you can see the M here stands for what? The mass, while the Q stands for what? The quantity of electric current that is passing through the electrolyte. But Q on its own means what? Current times times. Because the current is there, okay, measured in amperes, while the time taken is what? Is in T, that is measured what? Measured in seconds. Furthermore, we can now say that the mass here, okay, is proportional to what? To IT, where M equals to what? E times IT. What does E stand for? E here means what? The electrochemical equivalent, which is a fixed value in this law. Now, the second law has to do with what? With the number of moles that are present during the electrolysis. Now, the second law states that when the same quantity of electricity is passed through different electrolytes, the relative number of moles of the element's discharge is inversely proportional to the charges on the ions of what? Of the elements. So by the equation, we can use this equation to find the number of moles, the number of Faradays, and the mass of elements deposited during the electrolysis. Okay, now take note of the following facts. First of all, the quantity of electricity required for liberation of 1 mole of an ion is 96,500 coulombs. Don't forget, 96550 coulombs represents what? 1 univalent electron that is discharged during electrolysis. Now, if the element is discharged to 2 electrons, you multiply this value by 2. If it discharges 3 electrons, what do? Multiplies 96500 coulombs by what? By 3. You now get what? The quantity of electric current that is passed. Now, the quantity here refers to what? The numbers of Faraday, which is signified as capital letter F. Now, what is 1 Faraday? 1 Faraday is 1 mole of electron which contains Avogadro's constant, in which you know it is 6.03 times 10 to the power 23 electrons. Okay, so if it follows that 2 Faradays will be required to do what? Discharge 1 mole of ions of a divalent element or radical, such as maybe Pb2 plus, S2 minus, Cu2 plus, and many more. Okay, so what are the applications of electrolysis? We have, I'll give you just 4 here. 1, for the extraction of metals, can be sodium, potassium, magnesium, calcium, following what? The electrolytic process. What happened at the cathode with their raw form, like their off form, okay? Use it to what? To extract them. Okay, and then you can also extract non-metals from their raw form. Example, hydrogen chloride. For example, you can get hydrogen from where? From electrolysis of acidified water, which hydrogen is formed at the what? At the cathode. Then also you can also obtain chlorine from the electrolysis of brine, in which chlorine, okay, is what? Is processed at the end of the extraction. Also, to purify metals, example, copper, mercury, silver, gold. Then for electroplating of metal by another. We also used to do what? To prepare some important compounds, just like sodium hydroxide and many more. Okay, this will serve as an assignment after we have solved some past questions. So this, you will do it by yourself. Okay, when we have finished solving some past questions that have some related questions to this. Now let's look at the first question. These are related JAM past questions from electrolysis. Question 1 says, what current will deposit 3.25 grams of zinc in 2 hours? Now, you must convert the hours to what? To seconds. Because time is not measured in hours, but it's measured in what? In seconds. But you must understand the question very well. What are you looking for? First of all, understand the question. Secondly, try to do what? To write the half equation for the ion that is mentioned in the question. Then number 3, try to balance it if it is not balanced. For example, this zinc is what is a divalent ion, and it discharges 2 electrons. That is why you see 2 electrons. That's why you see 2 electrons here being what? Being balanced. Now this 2 electrons shows that it discharges what? To what? 2 electrons is what? Is being dismissed. Okay, it's being gained. Okay, from this zinc, because this is a cathodic reaction. This zinc gains 2 electrons and becomes what? A zinc neutral atom. So to balance this, don't forget that 1 Faraday stands for what? 1 Faraday means 96500 coulombs. So this is 2 electrons that it discharged. So multiply this value by what? By 965. You have 19, as you can see, you have 1930000 coulombs. Okay. Now, but the question is, you are looking for the current that we use to discharge this particular 3.25 grams of zinc. So you must find the quantity of electric current based on the time that is given. So what do you do now? So because you are given the time, you are asked to find the current, and time is what is given. So convert 2 hours to seconds. Now, how many minutes make an hour? 60 minutes. That is point number 1. Now, how many seconds make a minute? Is 60 seconds. So what do you do? So for you to convert 2 hours to seconds, you multiply, as you can see on the screen, you multiply 2. First of all, 2 times 60 to get to minutes, then times 60 to seconds. If we do that, you will now have 7,200 seconds. All right. Now go back to the equation. What is the given mass of zinc? Mass of zinc here is 65. Is 65 grams. Okay. So if 65 grams, okay, can be produced by 196,300 coulombs, then what is the reacting mass? What will be the coulomb produced by the reacting mass? You now cross multiply. That will give us your x column. If you cross multiply, that will give us what? 3.25 grams. As you can see, 3.25 grams times 19300 divided by 60. That will give us what? 96. That will give us 96. Yes, 9650 coulombs. But what is our target? Our target is to do what? Is to find the current that is used to discharge 3.25 grams. So go back to your normal relationship between quantity, current, and time. So when you get there, you make your I the subject of formula, because you have gotten your Q and you've known your what? Your T. So if you divide your quantity by your time, you now have a current of what? 1.3. If you check the option, the answer here is what? Is C. 1.34 amperes is what you need to do what? To discharge 3.5 grams of zinc. You can see the steps you need to follow before you can get to the final answer. It's not a direct question. This is how JAM set their questions. It's not direct question. Now let's look at another example. Okay, copper sulfate solution is electrolyzed using platinum electrodes. A current of 0.193 amperes is passed for 2 hours. The question is, how many grams of copper are deposited? Now they have changed the question here. In this case, you are given time. But in the fourth example, you will ask to find time. So let's see how this one is solved. First of all, where is copper deposited? At the cathode or at the anode? You must know that. Now, copper is always deposited at the cathode because cathode is a negative electrode in which the positive ion will be attracted to. After you have done that, now write your half equation for it. So that will give us our C2 plus. How do you balance it? Because copper nanowhat gains 2 electrons. That's why you have 2E. That's why you have 2E minus. Yes, 2E minus. Because copper now gains this electron and becomes what? Cu2 plus. Okay, so now you're given the mass of copper, but you're not given the reacting mass. Don't forget that 1 Faraday is 96500. But 2 Faradays will be now 2 times 96500. You have 19300 coulombs. So let's find the quantity first. How do you get quantity? Q is equals to IT. What is your I is given in the question, 0.193 amperes. How many minutes is 2 hours? Convert that to seconds. You have 7,200 seconds. Then multiply out by your time. You have 1389 watt 0.6 coulombs. All right. So this is what you will use to find the grams that copper deposits. So now, therefore, if 19300 coulombs discharge 63.5 grams of copper, what will 1389 gram discharge? When you do that, you cross multiply. So you now have what? 1398.6 times 63.5 divided by 19300. That will give us what? 0.457 grams of copper. So if you check the option, the right answer there is what? Is option A. Option A. So we have learned how to calculate the quantity of electric current in example number 1. Example number 2, we have learned how to do what? How to find the mass of a substance deposited during electrolysis. So let's pause it for now. When we come back, we'll continue from there.